So let's take a look at our agenda. What are we doing today? I don't want to scare you because it seems like a lot, but it's really not. Okay. So we're going to be at the hangout. I'm going to teach you a couple new things. This is something that you have never learned before, I'm pretty sure, in your entire life. So just pay close attention. You don't have to write it down if you don't want to. I think that it's easy enough where you don't have to write it down, but you do really have to pay attention. Then you'll get the pattern, then you'll be good. Okay, once you leave, make sure you have attendance written or done on Schoology, and then you're going to print or with Cami do the 2.1 and the 2.2 notes. So I think this is where I kind of scare you guys. You're like, 2 of them? I have to do 2 of them today? Guys, you're less. So here's your video. It is not Edgenuity. Here's your video, and here's your video. I promise you, the videos are like 8 minutes long. This one is 7 minutes and 58 seconds, and I think the other one is like 8 minutes and like 2 seconds, okay? So combined, it's only 16 minutes, okay? So you're going to submit them, download them, watch them, understand them, and then submit them for both of them, okay? And then there's the attendance. And please remember, if ever you are late for class, or if your internet lags, or if you can't make it because you have a doctor's appointment or whatever the reason is, there's always going to be after this class, because this is a class I record, because it's my, oh, well, I can't say that because then all my other classes will hear, because I love you guys so much. There's always going to be a link right here that says today's 20 minutes so you can watch it. Okay, so let's do this. Again, I can't see your faces, so if you have something to say, please just type it and Mr. Tucker will talk on your behalf, or please just unmute yourself and shout it out. Okay, so what we are talking about today is something called scientific notation. Okay, so again, you don't have to write this down, but you do have to pay attention and listen. Okay, scientific notation is basically another way that I can write a word, or sorry, a number. I want to, like, so let's say I were to ask you, I want you to go to the beach right now and count how many grains of sand there are at this beach, at, South Padre Beach. You're going to be like, oh my God, there's like billions, if not trillions or quadrillions of grains of sand. How can I possibly write all that down? So what if your number that you finally were able to count was like 79800000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 So if you write it in scientific notation, forever to even write this number. So if you write it in scientific notation, it's only going to take about that much space, and it's going to be the same number. So it's not going to be this long, and it's not going to take you that long. Or if I were to say, okay, did you know that on your bed there are millions of dust mites? I know that's disgusting, but there are actually things called dust mites. They're like little bugs in all of our beds. Even if you shower every day and you're like the cleanest person, you still, like, you lose dead skin cells all the time. And the skin cells have dust mites on them. And so there are all these tiny little bugs crawling all over your bed. Well, they're microscopic. So microscopic means they need a microscope to see. So what if I said, take a ruler and measure how big these microscopic mites are? You would be like, oh, well, if I use my ruler, this microscopic mite is 0.000000000000000. Let's say 1, 2, 3, 4. That many, centimeters long. Well, that's a huge number to write, because what if I said measure every dust mite? And then you have to write this over and over and over. Well, if you were to write it in scientific notation, it would only take about that much paper space. So that's what I'm going to be teaching you today. How to take really long or big numbers or really small numbers and write them shorter, so it doesn't take you like until next Tuesday to write a number. Okay, so there is something called standard notation, and that's the easier one. So that's what we're going to start with first. Okay, so let's write numbers in standard notation. So again, as long as you listen, you really don't have to write all this down, because it's easy enough where you can just get the pattern and understand it. So let's say I have something that's like 7.41 times 10 to the 4th power. Okay, I want to write this number in standard notation because right now I've written it in scientific notation. Standard notation means write the entire number, write the whole long big thing. So like this is standard notation and this is standard notation because it's the whole number. So if I wanted to write it in standard notation, this is what I need to know. I need to know this number and what number it is and whether it's positive or negative. So I see that it's to the fourth power. So what I'm going to do is I'm going to write 7.41, just copy that part down. It's to the fourth power, so I have to draw 4 loops and it's positive. Positive means go to the right. Okay, so I'm going to draw from this decimal, bloop, 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 bloop. I've just drawn 4 loops because this is to the fourth power. And then I have a decimal right here. I've just moved my decimal. Now, take an educated guess. What numbers do you think I should put in here as placeholders? Yay, you guys are so good. This is why I love you so much. And I probably shouldn't say that too often because I'm recording you, so I don't want my other classes to see or to say. It's like you never want to tell your kid who's your favorite kid, even though you obviously have a favorite child. Just kidding. Okay, so your answer is 74100. This is the number written in standard notation. This is the number written in scientific notation. Now, sometimes you can double check your answer on your calculator. 7.41 times 10 to the fourth power. Oh, look, so I can double check. I got it right. But you can't rely on your calculator because let me show you now why you cannot rely on your calculator. Okay, so let's say I have, I don't know, 0.12876 times 10 to the 10th power. Okay, so this means that the 10, the little exponent, tells me how many little loops I need to draw. And since it's positive, positive means to the right, so I'm going to go to the right. So I'm just going to recopy this part, 0.12876. I'm going to draw 10 loops to figure out what the answer actually is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just drew 10 loops. Here's where my decimal has moved. As you guys already said, add zeros as placeholders. So my answer is actually 1, 2, 8, 7, 6, and then 1, 2, 3, 4, 5, 5 zeros. So this is my answer in standard notation. So let me double check my answer. 0.12876 times 10 to the 10th power. By the way, the to the button, like how I got to the 10th power, is this button. Oh, you can't see it. This button right here underneath the clear. That's to the, okay, to the 10th power. So let me hit enter. What is it? Oh, darn it. The calculator proved me wrong. Okay, let me try 10. What if it was like 10 to the 15th power? Okay, let's see. This is where sometimes you can't always rely on your calculator. Do you see how it didn't write out the whole number? Okay, if it doesn't write out the whole number, how do you know what answer that is? The E tells you have to draw 14 loops. Well, obviously, but I mean, the point is your calculator won't always tell you the answer. Okay? All right, so let's do one more before I make it slightly more complicated. What if I just have like, oh, actually I want to do 2 more because there's 2 more complicated ones. Okay, what if I have like, I don't know, I'm blanking out here. What if I have like 7.98 times 10 to the first power? Okay, can someone shout out or can someone type out how many loops do I have to draw? What do we think? I have to draw loops. Okay, thank you. So I have to draw 1 loop. So here's I just rewrite it, 7.98. I just go bloop, and that's it. So here's my new decimal. So my final answer is just 79.8. So do you see how sometimes I'm not going to have to write zeros? Like if I don't have that many loops to draw, I don't always have to write zeros. Okay, here's a trick question. If you can get this right, then, you're pretty good. All right. I mean, because not very many kids get this. What if I have this? 7 times 10 to the fourth power. So first of all, how many loops do I draw? Thank you. Good job. Okay, so you draw 4 loops, but wait, like here, I started my loops with my decimal. Here, I start my loop with my decimal. Here, I started my loops with my decimal. There's no decimal here. Like it's 7, but where's my decimal? I don't have a decimal. So how do I draw my loops? Where do I put my decimal, guys? Behind, as in to the left or to the right of the 7? Yay! Good job. Guys, a whole number, think of 7 as like $7. How would you write $7? 7.00. Your decimal is always after. Okay, now I go bloop, 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 and then add a couple more zeros as placeholders. Final answer 70,000. And that's it. Okay, so it's not too bad, right? If you understand, oh, the exponent is how many loops you draw, then you should be okay. Now, what I don't want you to do is this. Okay, some of you just have, not as great handwriting, and that's okay. But when you draw your loops, you need to draw nice, big, fat loops like I am. Because if you're going like boop, 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 like that, like if you're drawing teeny tiny loops, how do you possibly know how many zeros to plug in? Okay, so please, when you're drawing your loops, like 1, 2, 3, 4, draw 4 really nice, big, fat loops so you know exactly how many zeros to write, right? I don't want you to get the answer wrong because your handwriting was too messy. Okay, so one more before we go backwards. Okay, what if I have this trick question? 10.83 times 10 to the negative fourth power. Negative fourth power. We haven't done that yet. So first of all, how many loops do I draw? Thank you. Good job to whoever said that. 4. Okay, so I'm going to rewrite it. I have 10.83. This one is different. Does anyone know why this one is different? Yes, you move it to the left. If it's negative, you go bloop, 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 bloop. You go to the left. So this answer is 0.001083. So do you see the difference? If you have a negative exponent, you go bloop, bloop, bloop to the left. If you have a positive exponent, you go bloop to the right. Okay, because negative means backwards. Negative means this way. Positive means that way, forward. Okay? All right, so that's the easier one. Now let's do the kind of more complicated, but not really that complicated. Okay, now let's go backwards and let's write it in scientific notation. Okay, so let's say my number is 12840000000. That's a huge number, and I want you to write it smaller. I want you to write it in scientific notation. So here's the rule, okay? What you have to do is you take your finger and you cover up all the zeros at the end. So I just covered up all the zeros. Now you have 1284, okay? So how you write this is you always write one number, the first number you see. Isn't the first number 1? And then you always write a decimal after, so point, and then all the other numbers, so 284. So do you see what I did? I covered up my zeros, write the first number, which is a 1, and then a decimal, always a decimal, and then 284, and then times 10 to the something. So 1.284, let me put my decimal there. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9 to the end. So it's to the 9th power. And boom, that's my answer. Okay, that's a little bit more complicated. So let's try another one. 2870. Okay, so remember what I do? Cover up all your zeros at the end. Oh, there's only 1 to cover up. Write the first number, which is a 2, and then you always write a decimal after, so point, and then everything else. 87 times 10 to the, so 2.87. Here's 2.87. Can someone type out or shout out to the what power? Yay! 1, 2, 3. You always just want to go to the end. Okay? All right. I have 2 more, and then we're going to make it even more complicated. What if I just have 79? Okay, so cover for zeros. Oh, there's no zeros to cover up. Okay, you always write the first number, 7, and then you always write a decimal, and then everything after that. Oh, that's just a 9. So times 10 to the something. So here's my decimal, 7.9, 7.9. All right, can someone different shout out to the what power? Yay, just bloop to the 1 power. Good job. Okay, so I had one more complicated one to ask you, but I just forgot. Let me think if I can think of why did I put the decimal here? Okay. Yeah, it's just the rule. Some math genius said, this is the rule, and that's the rule. One number, one decimal, everything after. One number, one decimal, everything after. That's just the rule. So if my question was like this, 0.12876, this is not written in scientific notation because it's not one number, one decimal. It would have to be 1.2876, not 0.12876. Oh, I remember the complicated one now. Okay, what if I have this? Let's say 6000100. Okay, so remember how I said the first rule is cover up your zeros? Wait, I have zeros here. Do you guys think I should cover up these zeros too? No, I should not. Okay, you just cover up the zeros until you get a number. So even though there are some zeros here, that's okay. Okay, so here's a rule: one number, 6, one decimal, and then everything after. So there's 3 zeros and then a 1. So 6.0001 times 10 to the something. So 6.0001 is right there. Okay, can someone count how to what power? Yes. Yay! Good job, guys. So remember, 1, 2, 3, 4, 5, 6. You guys are so good. Seriously. I love you so much. I can't see your faces to give you a big happy smile, but I truly love you so much. Okay, so back to this crazy question when I'm like, go to Padre Beach and go count the number of grains of sand. And you don't have to write this huge number anymore. You can say, well, Miss Friesenhan, let me cover up all my zeros. I have one number, a 7, and then a decimal, and then everything after, which is 98, right? And then times 10 to the what? I don't know, 7.98. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 to the 29th power. Isn't that so much easier to write than that huge thing? Okay, so give me 3 more minutes and then you're done. All right. So let's go backwards. What if this time I said, okay, now write this decimal in scientific notation? What if I said like 0.000123? So write that in scientific notation. Well, okay, cover up all your zeros. This time you're just covering up the zeros in the front, not the back. Write one number, 1. Write your decimal, point. Write everything after it, 23 times 10 to the something. So 1.23 is right here. We're going backwards now. 1, 2, 3, 4. You're going backwards to your original decimal. Don't go forward. You're going backwards to your original decimal. So it's to the 4th power. Is that right? Hannah, you are so close. Yes, silly rabbit. Friesenhahn, come on. It's the negative 4th power, right? Because you're going backwards. If you're going backwards, it's negative. If you're going forward, it's positive. Okay? Yes. Yes, you are completely right. Okay, let's do another one. 0.000100002. So remember what we do? We cover up all our zeros. Even though there's zeros here, don't cover it up because you have a number here. So how do I write this? Write one decimal, 1. Write a decimal, or sorry, write the first number, 1, and a decimal, and then everything after, 0.0002. Okay, times 10 to the something. So 1.0002 is 1.002 right there. I have to go backwards. Can someone tell me what this exponent should be? 4. Good. Now hold on. So 1, 2, 3, 4. It is 4, but you guys forgot something. Thank you. Good job, guys. Okay, last example, then I'm going to go to that crazy one. So 0.06. That's it. 0.06. So cover up your zeros. Write your first number, 6. Write a decimal, point. Write everything after it. Oh, well, that's it. There's nothing after it. Times 10 to the something. So here's 6 point. Okay, guys, what's this exponent? Thank you. You guys are awesome. Bloop, bloop. Hmm. Oh, like 6.0? I mean, really, you should just know that 6 point is just 6. Yeah, it doesn't really matter. 6.0, 6.6, either one's fine. You just have to know that the decimal's after and not before. Okay, so back to this one, our dust mites, our, beautiful, lovely, yummy dust mites. Okay, so here's the number. I don't want to write all that. So I'm going to cover up all my zeros and I'm going to write the first number, 1. I'm going to write a decimal, and then write all the numbers after, 2, 3, 4 times 10 to the something. Okay, I'm not going to make you count because you're going to get a headache. So 1.234 is here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so am I right? Is it 10 to the 22? Ah, silly rabbit, Friesenhahn. Come on now. It's negative, right? If you have a decimal, that's like a really small number, it's negative. If it's a whole number and it's really long, then it's positive. Okay, that's it for today. What did you say? Oh, thank you. Good job.